Morning, everyone. This is a cavernous space. I hear this echo that I'm not used to that in the other rooms. What this talk is about is something that I call design by coding, which is really, as I say in the subtitle here, extension of the whole notions of test-driven development, or test-driven design is actually how I like to think of it, and also of behavior-driven development. So I'm going to look a little bit at all three of those things. I'll look at how I do things, but also look at the underlying systems that I'm building on top of. The basic problem that I'm trying to address is the problem of developing code in an agile environment where you are designing incrementally as you're working. Is that what you have in front of you is a story, is a unit of work, and you want to design in such a way that you can add the capabilities required by the current story in a way that will give you architectural consistency over time as the whole system is developing. And you can do that in many ways. It's a continuing thread through a lot of the sessions I've been giving in this conference is that at the center of this is object-oriented thinking in the sense of modeling the domain in order to produce a program and getting a one-to-one correlation between the domain model and the software. So if, for example, you've got a ordering system, you'll have an order object and a customer object, and the customer might have an address object in it, and the order might have line items in it, and the line items might have, inventory items in them, and so on and so forth. But those are all domain-level concepts, and they would map directly to classes inside the systems that we were building, assuming that we're building in an object-oriented language and we have classes. So the idea is to try and keep that one-to-one correlation. So the question is then, from a development point of view and also from an agile point of view, how do you do that without having this massive upfront design effort and also a massive pile of documentation? The documentation in particular is anathema in the agile world, though people misunderstand that. As often I will hear people who don't understand agile saying, well, agility, we have no documentation in the agile world, and that's not actually true. You have a lot of documentation. The issue is that the documentation is at a place where it will do some good. Or to put it another way, if you have a document that is separate from the code, first of all, the odds of that document actually describing the code are zero. Right, you'll spend a lot of time putting the document together, but within 10 seconds, the code will have changed and the document will have not, and you've got nothing. The other problem with those kinds of documents is that most of us realize that problem. So HP did a study of documentation, probably 15 years ago now, a long time ago. And one of the things that they found is that nobody reads it. And you'd think that we would have all known that, right? How often have we actually read the documentation for the systems that we're working on? Even when we come into the company, right, as a brand new employee, you pick up this huge stack of documentation and read about 3 pages of it and say, the hell with this, and you go find somebody who can explain it to you, right? Is that nobody reads that documentation. So from an agile point of view, we would say that's waste. No reason to build it. What we do want to do, though, is we want to write the code in such a way that it is self-documenting, which is to say that the documentation is the code itself. So it's not like there is no documentation. It's rather that the documentation and the code come together. So when you need comments, obviously that's part of the documentation. When you have some kind of preprocessor that generates HTML documentation, that's also part of the documentation. And everything is dynamic, though. If there's anything written down, it's written down in a wiki format, typically, so that it's easy to change. So the problem I'm trying to address here then is how to write this kind of self-documenting code in an incremental way. So I don't have to do a lot of upfront design before I start actually coding. So that is the problem at hand. Now, I made a little video about this. So if you want to follow on to the things that I'm saying, this is about a 10-minute long video that will distill pretty much everything that I'm going to discuss over the course of the next 90 minutes. I have it up on my website. I also put it up on YouTube. That's just the Google thing is just a shrunk version of the longer YouTube URL. But the process is pretty straightforward and it's pretty easy to describe. So it's built on top of TDD. TDD itself is a design practice, which is something that people don't understand when they look at it. They think of test-driven development as being a way to produce tests because it has the word test in its name. And in fact, when you learn about agile process, often you will hear the exhortation that you should write your tests first. which in practice you might or might not do, is that you will certainly write your tests at the same time as you write the code. Whether you actually write them first or not is another matter. Some of them you will write first. The acceptance tests you write before you write any code. The unit tests you might write as you're writing the code or not. Now, if you're doing strict TDD, you will do the unit tests before you start writing the code also. The basic thing that people don't understand, though, is that the point of those unit tests is to be able to write the correct code. The point of the unit test, in other words, is to find flaws in your thinking. In other words, you're doing a design process if you're finding flaws in your thinking. The tests that you end up with are useful tests, but it's nothing like the full set of tests here that we need in order to actually make sure that the program is working. So any kind of tests that come out of any kind of TDD-based process are going to be incomplete by their very nature. Because the point of the exercise, then, is to develop good code, not to develop tests. The fact that we get a bunch of nice tests, well, that's nice, but it's, it's really a side effect of the process. It's not something that we're aiming for. So what are we trying to do by doing this process? We're trying to, well, remove stress. Is that if your tests are in place, it's way less stressful to work on the code. Because if you run the tests and they work, and then you make a change, and then you run the tests again and they don't work, you know exactly where the problem is. And when you're doing any kind of TDD sort of work, you are testing, oh, I don't think I go more than 5 minutes without running my tests. And 5 minutes would be unusual. It's typically I'm running them once a minute or so. So the side effect of that, of course, is they must be automated. There's no way that you can do this kind of testing if it's not automated testing. But it takes all of the stress off the code. I never look at a piece of code and stare at it for 10 minutes to try and figure out whether or not it's going to work. I just run the test. And if it doesn't work, it's probably going to take less time to just throw it out and rewrite it than it will to try and figure out what the problem is. So it radically changes the way in which you put code together. As a consequence, it's also reducing my development time, because I'm not spending a lot of time staring at the code trying to figure out whether it's going to work or not. Is that programming, as we all know at least, is largely an intuitive activity, right? You do what looks good, you do what feels right. And it's not an analytical activity, as none of us do mathematical analyses of our programs in order to determine whether they're correct before, as we're coding or before we decide to run tests on them. That's an interesting academic exercise, but it's not the way that we really work. So if we can just program by the seat of the pants, if we can program intuitively, thinking this is the right way to do it, we actually develop code faster than if we have to sit and do a lot of analysis on the code as we're working. So having a large number of small tests in place and being able to run them in an automated fashion allows us to work that way, because we can tell immediately when our intuition has led us down the wrong path. It makes it easier to refactor. Is that refactoring, as we all know, is the process of taking a piece of working code and making it better without breaking it. We don't change what it does, we just make the code quality better. Well, if you don't have these kinds of tests in place, you cannot refactor. It's that simple. And this is a good example of how agile processes tend to mesh with each other and interact with each other. Is that one of the common agile practices is this notion of test-driven development, right? Is writing the tests first. But then refactoring is a big part of any kind of agile process. Aggressive refactoring. Merciless refactoring is the phrase that they often use. The thing is that you can't refactor if you don't have the tests. It's not possible. And when a company is moving to agile from a non-agile way of working, the first thing you always have to do is write the test. There are never enough tests if you have not been working in an agile way. So the very first thing that you have to do, and just to make the code usable, you make the code maintainable, make the code so that it can be expanded in a flexible way, is to put tests in place so that when you make the changes, you can guarantee that you haven't broken anything. So the very first thing that any company has to do if you're thinking about moving in an agile direction is to spend 2 or 3 weeks doing nothing but putting unit tests in place, because I can guarantee you're not going to have enough of them. One of the advantages of another advantage of writing the test first is you end up with 100% code coverage. Now, that will become more clear as I go more into the process, as I describe how the process works. But the test coverage ends up being very, very complete, for the simple reason that what we're doing is allowing the story to drive the code development. And again, I'll get into more details in a moment, but the basic idea here is that we write up an acceptance test first. And the acceptance test is going to be doing something. It's actually going to be walking through the story. It's going to be exercising the system, walking through the story as if the system existed. So we're writing to interfaces. We're not actually writing to real code because the code doesn't exist yet. But the important issue here is that if the interface is a minimal interface, and it always should be, in other words, the interface that we're coding to does exactly what we need it to do in order to implement the current story and nothing else. And then when we go to implementation, if we implement exactly what we need to do to make the story work, or to put it another way, if we implement exactly what we need to do to make the test pass and nothing else, then we have no unnecessary code. Every line of code that we have written has been focused like a laser on getting the current story to work. And since the test is what's driving that process, what that means is we have not written a single line of code that's not going to be exercised by the test. And that's really important. So we end up with 100% test coverage, which is a hugely important thing. And the other thing that we get out of that is we get the minimal code set. So what you have to resist if you're going through this process is the tendency, which we all have, to look at something like a function call and go, if I only added this extra argument, it would sure be a lot more flexible. You don't ever want to do that. Because if you add that extra argument, you're going to be adding paths through the function that are not tested. Because it's covering some future eventuality which is not in the current test. Moreover, you're going to make the function more complicated. It could be as much as twice or 3 times more complicated than it needs to be in order to handle the extra argument. One of the basic metrics that one uses to measure complexity in code is cyclomatic complexity. You can buy and also download now, there are open source tools that will analyze a program for cyclomatic complexity. It is by far the best measure of complexity that you can have. And it's doing a very simple thing. It's just basically what it's doing is counting the number of branches there are inside functions. Cyclomatic complexity numbers should be very low, in the 3 or 4 range. In other words, there should only be maybe 3 separate paths through a given function. And if it gets higher than that, the code gets almost impossible to maintain. One of the first things that I do, again, when I look at code to see whether it's worth dealing with at all is run a cyclomatic complexity metric on the code. Often when I go into code that was developed in a procedural way, the complexity numbers will be up in the 50s. And remember, I think that 4 is okay, and I'm really worried about 5 as being too complex. And I find numbers up in the 50s. So the point here is that that code will not have 100% coverage, I can guarantee it. Is that all of those extra paths, the vast majority of them will be paths that are never followed by anything in your program, which is a big deal, right? It took a lot of time to write that code. It takes a lot of time to maintain that code. It takes a lot of time to make any changes, because every time you make a change, you've got to look at all of this code that is never called. And we really want to avoid that situation. So working in this way, by doing the tests first, tends to let us get to a program that doesn't have all of this extra baggage in it. It improves the architecture as a consequence. The architecture gets much simpler. You want the simplest possible architecture you can have. And that's, of course, a good thing. Now, this is all based on the notion of mocking. Is that the way that we're working is based on the notion of mocking, because remember, I said a moment ago, we're coding to the interfaces. Well, in order to run a test, the interface has to be implemented by something. You can't just run an interface. So the idea of a mock is that a mock is a very, very simple implementation of an interface. Simple enough to run, simple enough to succeed in the sense that when I run through my test, I start out with it succeeding. The state you always want to, they say go back to green. You always want to be in a situation where the tests all pass, even when you haven't written a line of code yet. So the mock is the basic implementation of the interface that does literally nothing other than what you need to do in order to get the test to pass, which means that most of the methods will be 1 line long and they will return true or return false. Right? They're not going to actually do anything except pretend to work. Now, mocks you can hand code, and often I do, but you can also generate them in a machine, with a machine. So there's a lot of mocking frameworks. In the .NET world, I've used MOQ. In the Java world, I've used PowerMock and Mockito and those kinds of systems. There's a lot of systems that will generate mocking implementations for us. But truth to tell, those are handy, but they're not essential, is that you can do this stuff by hand very, very easily because it's so simple, is that the generated mock is really just a bunch of return trues and return falses. It's not going to take that long to write the thing. Looking at the things we're testing, we also have to think about the environment within which we are testing. In other words, there are going to be 3 layers here. There's the object under test itself, but there are going to be clients that use the object from the outside, and those are easy things to test. In other words, if what we want to do is monitor the messaging flow into a system, we can take the object we want to test and just wrap it with an object that has the same interface. And in fact, that's what most mocking frameworks do, is they take a class and create a derived class that overrides every method of the base class with one that just returns true or false. So that's testing from the outside. That's easy. Testing from the inside is a little harder. In other words, when we're testing an object, we want to be looking at how it interacts with its surrounding context. And the surrounding context can be clients to the object, but the object uses things. And those things that it uses are also surrounding context. So one of the things that's going to happen here is that we have to, oops, that's really saying the same thing the last code did. Oh, I got a slide in the wrong place. But just ignore this slide for a second and look at me, is that we're going to be using some kind of dependency injection system in order to make this work. In other words, part of the coding process, in addition to doing the mocking, is we have to tell the object, I want you to use this instead of that when you do work. So for example, if you wanted to test that some internal data structure was in the state that you expected it to be in after a set of messages ran, you can't use a default off-the-shelf hash table or something for doing that because it doesn't have any logging capability in it. So you have to pass into your object a version of the hash table that can log the fact that things have been added to it so that you can verify that things worked correctly inside your test. So you're often injecting into your object things that are needed for the tests to work, which means that you've got to be thinking about that as you're doing the coding, is there have to be ways to get those objects in the center into the object somehow. Depending on the language, you may be able to do that with introspection APIs, but more often than not, it turns into constructor arguments, things that are passed into the object when you create it. So when we're testing using a mock, the basic idea is that we're simulating the clients and the servers, the things in the middle and the things on the outside. We are not using real things, we're using fake things that are just measuring the fact that they have been used. So again, using the inner data structure as an example, when I put something into the data structure, well, it'll do that, but it will also log a message saying, I've just put this into the data structure. So it's giving us some information about how things are interacting. And again, we can use a mocking framework to do this, or we can make our own. It's not that hard. There's also the notion of spying versus mocking, which is an important distinction. The basic idea of a mock is you start out with an interface and you create a fake implementation of it. The basic idea of a spy is that you start with a working object, and then you put a wrapper layer around it that just monitors flow into and out of the object. So spying and mocking, if you go into the test-driven development literature, you will find that they don't like spying, is that they think that the notion of spying interferes with the basic things that you're trying to accomplish with test-driven development. And to some extent, that's true. In design by coding, in my notion of how we should be approaching this problem, spies end up being extremely important, is that you end up using spies a lot, because what you're doing is implementing a story. And as you are working your way through an implementation, you're building on the things that have happened before. In other words, the vast majority of classes that are in use in your implementation will already exist. It's not like we're creating them from scratch. But we still need to monitor the way that those things are used. So spying is a great way to do that. It's going back to our hash table example. Rather than creating a hash table class of my own that does whatever I need for this particular test, I'm much better off just spying on a hash table. It's just taking a hash table and putting a wrapper layer around it with the same interface and having that wrapper layer do what I need to do for the test. But since I want it to actually act as a hash table too, wrapping an existing hash table is a much better solution than producing a mock which doesn't actually have a real hash table underneath it. Right? So the notion of a SPI becomes more and more important as you start thinking of this as a way of developing code as compared to, or a way of developing stories rather than as a way of developing simple code. There's my dependency injection slide. I knew it was here someplace, is that it needs to move forward, obviously. All right, so looking at the TDD process, the way that it works is you start by adding a small test to your system. And by small, I mean small. So it's going to be exercising some aspect of how the code or how a class works. Then you run all your tests, and the new one should fail, right? In other words, the test is testing something that doesn't exist yet. It better fail. Testing some capability of the object that doesn't exist yet. Third step is that you make a very small change, the smallest change you possibly can in order to get the test to succeed. And then you refactor in order to remove any duplication, for example. Often the process of making that small change involves adding some duplication to the system. And then you just keep going around and around and around and around that circle. That circle might take 5 minutes, if that. If you want to follow the test-driven development process, I'm not going to actually do that because it's actually lower level than I want to talk about in this session. Kent Beck's original book called Test-Driven Development is a really good book. And unfortunately, Addison Wesley, who publishes it, doesn't understand how important a book it is, so you cannot buy an electronic copy. You can only buy paper copies. They have never bothered to turn it into an ebook. And because there's some idiot who's saying, well, this book is too old to be worth turning into an ebook. In fact, it is just as valid today as it was the day it was written. So I strongly recommend that you get the original test-driven development book that Kent wrote. Now, the main concept here is getting to green quickly. This idea that we want to always have things working. The code is always working. So when you write the test, the first thing you always have to do is make it run, and you use whatever kludge you possibly can to make it run. You want to get back to green as fast as you possibly can. So you're either faking it or you're using some kind of obvious implementation, but one way or another, you have to make it run, and then you make it right. So that is kind of going against the grain for most of us, as most of us want to start out by actually implementing, by making it right. And it's much more important to make it run first, because if we start out in a state where it runs and we're always bringing it back to that state, that makes our lives much easier. If you start trying to do the implementation first, it might not run for 20 minutes, which means that you don't have any of the advantages of it used to run and it doesn't now, so what I just did 30 seconds ago is the problem. So getting it to run again quickly is an extremely important part of TDD. You never want to add a test when the tests are failing, because the whole point here is for the code to always be working. If you add a test when the test is failing, now you're in a position where you start adding code without knowing whether the code that you added was destructive or not. And that's again, a very bad place to be. You should be using lists as you do this, to-do lists, because as you write tests, things occur to you. And if you just do whatever occurs to you as it occurs to you, you'll be doing too much. You'll be making too many changes. So it's very important to I just keep a pencil and paper right next to me and write down the tests. I suppose if I was a little bit less physically inclined, I could just put it into a little text file. But one way or another, keep a to-do list. This is not a Kanban board, right? This is just a to-do list. It's just a list of things that, oh yeah, I forgot I need to implement that. Now, the minute between runs is kind of interesting. This is an excerpt from Kent's book, where he actually measured the average time between test runs. So notice that the biggest number there is 0, which actually means less than 1 minute. So more often than not, the vast majority of test runs are happening, 37% of almost 40% of the tests are running at an interval of less than a minute from the last time he ran a test. Right, the highest interval is, you know, as you can see, it goes down here as it gets longer and longer and longer, except there are a bunch of tests that take longer, right? In other words, there's always a piece of the code where you really have to stare at it in order to figure it out and make sure that you get it working. So there's always some chunks of code that take more than 10 minutes to write. But that's really the exceptional case. That's not the usual case. The vast majority of the code that we write, in order to get back to a test at least, can be written very, very quickly. Now, moving on in the direction of DbC, the question is, how do we design good interfaces, not just test them? And this question that I'm pondering here is one that I ask myself a lot when I use APIs that come from organizations like Apple or Microsoft or Sun or Oracle, is these guys just all drive me crazy, right? You use these libraries and it's insane. It's like no programmer has ever, there were no programmers involved in the making of this API, right? You look at it, what clown came up with this, right? What were they thinking that I was actually trying to do here? And it's always the fact that very simple things are very complicated to do because of all this flexibility that I'm never going to use, all this flexibility that nobody's ever going to use, because some idiot is sitting in a vacuum saying, well, I don't know what they're going to do, so I'll let them do anything. And that's really a bad way to approach API design, is that I would argue that the best way to do API design is to write a program that does exactly what's needed, and then extract a subsystem from that program, and what it does is what it does. That's your API. If you want it to be generic, more generic than that, well, write 2 programs or 3 programs using the same subsystem, and that'll make the interfaces a little bit larger. But you don't want to put anything in there that's not necessary. You don't want unnecessary flexibility. You know, people talk about writing code in such a way that you can expand it or adapt it later on as the needs of the system change, and that's an important thing to do. But that doesn't mean that you should write it off the bat so it can handle any eventuality that you can ever conceive of. What that means is you have to write it in such a way that you can add capabilities later, not that you have to add them now. So generally speaking, then, we want to make our APIs as clean as possible, and we want them focused very tightly on what we're actually trying to do. And the problem here is this clown is making guesses about what we want to do, and I don't want to work from guesswork. So I want to come up with a system here, then, about the right interface that's not based on trying to guess what the right interface is, because I can't guess right even with my own code. How am I going to guess right with respect to somebody else's? Or to put it another way, they're doing things backwards. Is that if you're really going to design an API that's going to be focused on what you want to do, you have to write the client code before you write the subsystem that you're putting an API around. Otherwise, you really are putting the cart before the horse. Or to put it another way, in order to figure out what the API for the subsystem should look like, we want to see how we're going to use the API. The important question is, how am I going to use this? And rather than guessing how I'm going to use it, we're much better off to actually write that code. Now, the code that we write isn't going to do anything because the API that we're writing to doesn't do anything. It's a set of interfaces that we've mocked in order to get things to compile. But you can learn an awful lot about an API by trying to write a program that uses that API. And you can find almost all of your flaws, almost all the problems with the API, by trying to write a program that uses the API first. And believe me, it's going to take way less time to go through several cycles of trying to use the API, thinking that the API is garbage, and then rewriting the API. Right? That might take some time, but it's going to take way less time to do that than it is to make those same changes after the API is implemented. If we're working with interfaces, there is no implementation on the other side of that client code. All we're trying to do is to make sure that the calls make sense, that there's a minimal number of them, that we're passing exactly the arguments that we need to pass and nothing else. More importantly, that we're getting back out of the methods the information that we need to get work done. Right? And we can find out all of that information without actually implementing the subsystem. By subsystem, that could be something as small as a class. So we're way better off than starting off with the client code. You want to write the client code before you write anything else. So the basic process then is you start off with a user story. And I mentioned this back in the keynote, I'll repeat it, is that the idea of a story is that a story is a narrative that takes the user through the process of doing something with the system that will generate an outcome that is useful, is valuable to our user. Logging in is not a story because it produces nothing of value. Adding a menu item is not a story. That's just a functional requirement because adding a menu item will not produce an output of value. Right? In order to be a story, it's got to be a narrative that is taking our user through the process of doing something at the domain level. Is this making sense to everyone? Now, there are a lot of reasons why we have to focus on that domain, but the main one is that, as I said a moment ago, we want to end up with a system where there's a mapping, a direct mapping, between the domain and the code itself, so that objects that exist at the domain level also exist inside the code, and they interrelate in the same way in both worlds. If you were to misdefine your story, and that happens a lot, is that a lot of the work that I do involves going into companies that are trying to transition to Agile and help them do that. And one of the things that is done wrong more often than anything else is that these companies have been used to working in terms of functional requirements. They hear about stories. They hear about that as a X, I need Y to do Z form, and they figure if I can take this functional requirement and put it in that form, it's a story. They use the word story and functional requirement as if they're interchangeable. And that's just nonsense, is that a story means story. It's the same definition that you get when you look it up in a dictionary. So a story has to be a narrative, and the whole point of that is to try and keep things focused on the domain. If you're taking, as a user, I need a menu item to do X, that tells you nothing about how the domain works. Is everyone understanding what I'm trying to get at here? So getting the stories right is very, very important, and they must be actual stories. So when I teach Agile, I spend a lot of time on story development, because getting the story right is really the center of everything. And it's got nothing to do with functional requirements. If I'm handed a list of functional requirements, the first thing that I do is say, okay, you want me to add this menu item? Why? What are you doing? What's the domain level process that you're going through that would be made more effective if I added this menu item? And once you learn that, once you learn what the story is, then you can make some decisions about whether the best way to solve that problem is by adding the menu item. Usually it's not. Usually you're better off doing other changes. The reason the functional requirement exists, though, is because whoever came up with that requirement couldn't imagine that we can actually make a change that would make the program better. All they can imagine is that we can add stuff to the existing code, not that we can improve the existing code. I'd much rather improve the existing code and make the program better than just adding all these accretions over and over and over again until we have this huge pile of menu items, right? Is that all of us have used Microsoft Word, is God. This is a great example of why accretion is a bad idea, there's too much stuff there. And most of the stuff is stuff that we're never going to use. So we start with a story. Next thing we do is we invent the interface that we wish existed. We invent an interface that we can code to in order to implement that story. And it will be wrong, I can guarantee it. So we start coding the story to this interface, and in the process of doing that, we will discover and fix flaws both in the interface and in the story. There will be some things that we will get wrong when we get the story, when we do the initial story. There will be many details that we don't know, it turns out. So that's another issue with respect to the Agile process, is that the story that you start off with, right, as a customer, I need to be able to add a new item to my order. Right, there's a story. But the thing here is that I might not have all the details right in that story. I have to be talking to my customer as I am implementing. Is one of the key requirements for any kind of Agile implementation is that you have an on-site customer. It's one of the things that I really detest about Scrum, that they don't have on-site customers. What they have is a customer surrogate. Moreover, the customer surrogate, the PO, is not maybe a customer representative at all, because his main job is to represent the business. And the business may or may not be talking to the customers. If you're going to really do Agile right, you've got to be talking to the customers. Is everyone following what I'm saying here? I'll give you an example of wrong versus right. Let's think about how the Amazon checkout page works right now. Right? Is you do a bunch of orders, and I can guarantee that all of us have exactly the same goal when we hit the I want to buy it button. And that goal is to leave the Amazon site as quickly as we possibly can. Right? Is everyone with me here? Well, if you have an implementation of that story that didn't take that goal in mind, what you'd end up with is the bad checkout processes that we've all seen, where you have to go through 6 different screens. And each one has to be done right. And sometimes you have to go backwards, but you try and go backwards and it doesn't populate the screen properly. And we've all wrestled with this garbage. Right? Well, that's because they're not focusing on the user story when they write that code. They're just thinking about the data. I need to collect this data in order to check out. Well, the data is the least of it. What I care about is the process that I need to go through. And I have a requirement as a user, as a customer, that that process be painless. So the other indication that I see when I see these bad checkout pages is that nobody sat down with the customer, not even themselves in the role of customer, and thought, is this reasonable? Is this something that I'm happy with as a customer? So when you do that, when you sit down and start talking to your customers, the stories change. So as a customer of Amazon, I need to add a new item to my order. That's a very minimal representation of the story. That's not enough to implement. That's enough to maybe decide whether I want to implement. That's enough to say, this is a more important thing for me to be working on than that. But once you start implementing, you need more detail. Now, the way you get the detail is not by having a mini waterfall inside your iteration. You don't then spend a day designing before you start implementing. You just start working. But in the course of working, questions will come up which would otherwise have been answered during the upfront design process had there been one. You still have to ask those questions. You can't write the code without asking the questions, without getting an answer, but you're not doing an upfront design process, so you have to ask the questions while you're coding. That's why you have to have your customer on site, because if the customer's not sitting there in the room with you, it's going to take way too long to get answers, which means that you're going to be tempted to not even ask the question. You're just going to guess what the answer is, and now we're back with that clown. So the customer's got to be there in the room. There's no way to get rid of the customer, move the customer out of the room. Anything that you do that moves the customer out of the room is going to introduce problems into your system. So one of the things we're doing here then is refining the story. We're not just refining the code, we're refining the story as we work through this process. Because the customer is going to be sitting there in the room with us. As we try and implement the story, questions will arise, and we need to ask our customers what the answers are. Notice that we don't need to document any of this, is that one of the efficiencies that you get in an Agile world is getting rid of the documentation that you would need to transmit information that you discover from your customer at the requirements gathering phase to the programmers who need to use that information 3 months later. Right? Well, if you can just ask the question at the moment it pops up and then write the code, you don't need to write it down. You've written the code. That's good enough. So all of the time that's spent writing documents, the sole purpose of which is just to transfer information to somebody in the future, we can eliminate all of that stuff, which makes the process very, very efficient. So going back to that story notion then, the as I want to, so that format is not a bad format. At least if we do it right. Now, bear in mind though that what we're as here is not user or something like that, right? It's got to be an actual role in the actual system at the actual domain level. Right? In the example here, as a banking customer, right? Or as a client of the bank, or something like that. And then what you need to do is some customer-related task. I want to withdraw some money from an ATM. Is everyone with me here? I, as a customer of the bank, do not want to add a button to a menu, believe me. That's not my goal when I sit down with the banking website. I want to check my balance. I want to transfer some funds. I do not want to add a button. And I want to do that for a good reason. There's got to be an outcome that I'm happy with. In this case, the outcome is that I don't want to wait in line. But the point here is that the outcome's got to be something that's meaningful to the users. One of the things that somebody just mentioned this in the session that I taught on Monday, and I think it's a great idea, is that you could rephrase this backwards. You could say, in order to achieve this value, a banking customer needs to do this. And I kind of like that. I like the idea of putting the value first. It gets you focused nicely on what you're trying to accomplish, right? If you're not accomplishing something valuable, it's not worth doing. So I like that. And at some point, I'll change this slide to flip things over, I think. I like that format. So the next issue, though, is that we need to keep the stories in sync with the code. So at the top, we've got a story. At the bottom, we've got an interface. But there's a one-to-one, as the names are the same, right? And I've got a dragon, I've got a dragon. I have a knight, right? The knight has to fight the dragon, so the knight interface has a fight method on it. Is everyone with me here? It's a brave knight, so I have to check to see if the knight is actually brave or not. Right? Notice that I'm not using get brave status here, right? Because I'm asking a higher level question than that. If I make a change, then I need to make the change in both places. But notice how easy that was, because there was a one-to-one between the original and the code. So that's our goal, is to keep those two things in sync with each other so that as we make changes, it is both obvious and easy about what we're going to have to change. So that gets me into my entire DbC process, which is a lot like the TDD process, but it's at a higher level, is that we start off by designing an interface based on the story, in the same way that I had my knight interface based on the incoming story. And then I develop what really is an acceptance test. It's a test that simulates the story, that pretends that it's some outside agent taking the knight through the process of fighting the dragon. And what it's going to be doing is using the interface to do that. As we do that, we will find problems in the interface. I can guarantee it. And what you'll do then is tweak the interfaces, right? So every time I do this, I always do it too late, and I always regret doing it too late, right? Is that I design an API, I'll sit down and I'll spend like half a day designing an API, and then I'll start trying to do this, and the API will be just completely wrong. And I keep trying to force myself to do this 5 minutes after I start designing the API instead of 3 hours after I start doing the API, and I never seem to be able to force myself to do that, but I'm getting better at it. Last one I did, I was at least down at the 20-minute range instead of the 3-hour range. But the sooner you can start in this loop, the better off you are. If you didn't have to do any changes to the API, well, then you're done with the design phase. Is everyone following me here? Then you drop down into TDD and start developing the code. But we've got an acceptance test here that's green, because we are coding against an API which is mocked in order to succeed, to appear to succeed. So now I can start expanding each one of the methods, one method at a time, using TDD techniques. And that will generate a few more tests, a few additional tests, which is fine. And gradually the code will be expanded until it gets to the point where it actually works. Each time around the TDD cycle is about 5 minutes. Each time around the DbC cycle is also about 5 minutes. So we're not spending much time. We don't want to do much between iterations here. And even 5 minutes, I'd say 5 minutes is probably an upper limit. All right, now, we can also look at it this way, somewhat more macro view, where we're picking a story, we're implementing a fragment of the story, stubbing out the implementation, and then getting into the run refactor loop. It's just another way of looking at the same process. So this all ties into other testing methodologies. As we've looked at TDD, let's look at behavior-driven development for a moment. What happened to the word development? I don't know what happened to the word development, but it used to say behavior-driven development. The basic idea of the behavior-driven development is we also look at a test. But in BDD, there's this notion that the test name should be a sentence that tells you what you're testing. And I think that's a really good idea, because you can have a one-to-one mapping between the actual test method and the output of the function that can be generated in an automated fashion. And I don't know if any of you took the Cucumber session, that I think was yesterday, but Cucumber does that kind of stuff for you automatically, which is pretty nice. So you start off with code and you generate some output that actually looks like English. It tells you whether the test passed or not. So the first order of business then is that Dan figured out that the test method should be real sentences. But it's better yet if you express it in a form that shows you what you expect to see happening when you run the test. Right? The test should fail when some condition holds, and then specify the condition. Right? Now, if you start thinking about this, what we're really doing is defining behavior here then. I have a little order class, and I've got an order test, but the test is checking that some customer is a valid customer for this order, for example. That's really behavior that we're testing. Does everyone see what I'm getting at? We're not testing state. Let's put it that way. I'm not looking at the state of the order object. I'm testing that the order object behaves the way it's supposed to when I ask it to do certain things. So by doing that, I'm doing a kind of analysis. I'm trying to decide what the behavior should be for this object. Exactly how should the object behave? Not only is it a kind of analysis, but the tests now can be created by the users, effectively, as a way of describing the problem. Is everyone with me here? So essentially, the set of acceptance tests that I end up with at the end of this process is my requirements document. But it's a requirements document that's focused specifically on stories. It's not focused anymore on buttons and things like that. It's focused on stories, on what the acceptance test could look like. So Dan, in BDD in general, suggests this kind of form. Right? We're testing to see, for example, that an account has sufficient funds. So given that, given this and this and this, when this occurs, I want to see this result. Then I should see this result. But again, this is focused on the story. And whether you have these chunks right is something that your users can tell you. So this is a way, what he's come up with then is a way of talking to our users to come up with a set of acceptance tests, which we can use to verify that the behavior of the system is what we expect it to be, which is very much in line with what I was just talking about with respect to the way design by coding should work. So these two ways of working are very much in sync with each other. Let's look at another example for overdraw here, right, is that now we're giving that the account is overdrawn, because obviously we can't test for it being overdrawn unless it's overdrawn. Right? And when the customer requests cash, then we want to ensure that there's a rejection of some sort. We want to ensure that various things happen. So in BDD, we just take that and translate directly into an executable image. Right? This is really exactly what we were just looking at before, except we've expressed it in code rather than English. Is everyone following what I'm doing here? There are various testing frameworks that let us do this. This is JBehave, which was the original one, but Cucumber has a similar kind of structure. But it's using the at given here and at when and at then, which directly maps to the specification form that we were looking at earlier. So we can get a one-to-one between the code and our user communication. Okay? So just to kind of finish up the sort of formal discussion is that we have then a set of general principles that are of interest here. The test should be abstract as possible. You want to be testing by looking at external behavior. Now, of course, if you're testing against an interface, you have no choice because there is no internal yet. So you want things to be very abstract. When the test fails, there's only a couple of possibilities. The first one is that it's a bug, in which case you fix it. The second one is that the behavior that you're testing has either moved somewhere or been removed or something like that, in which case you have to change the test. But again, remember the rule that I mentioned earlier, you never want to change a test while it's red. So what we want to do is put things back into the state where we were green, then move it, then run the tests, then introduce the new test. Third behavior is that the problem is that the behavior you're testing isn't correct anymore, right? Is that the specification has changed, in which case you don't want the test anymore. There's no point in testing behavior that we don't want. And those really are our three options. You want to decouple the test from the code as much as possible. So that gets back to this notion. I keep bringing this up because it's such an important notion. But at any moment in a system's life, at any moment in an object or a class's life, if you've designed the class properly, it should be possible to completely replace the implementation with a different implementation. As long as the interface hasn't changed, nobody should care. From a maintenance point of view, we desperately need this behavior. From an agile point of view, we need this behavior because what happens inside the class will change radically as the stories get added to the system. If we are messing around with the class definition in such a way that, the structure of the class has to change, we don't want all of the existing client code to break. Is that if that happened, we couldn't make any progress. So one of the side effects of this rule is you can't use getter and setter functions or properties. If you're doing any of that, just stop. Of course, you have to use them when you're talking to the Microsoft libraries, but don't use it in your own code. Because if you're exposing a property, then you can't change that property, right? Even if you're exposing something as simple as a type, if you're exposing something as an int, and then another story comes along and suddenly it's got to be a double, all of the code that uses that int is going to have to be rewritten. From a maintenance point of view, that's just too hard. So you want to write the interface to the system in such a way that you can make any change at all to the implementation, and that won't impact the classes that are using the object. Now, I'm not going to have time to tell you how to do that here. That's what I did Monday when I was doing my design architecture class. But it's doable, and but the general approach is the approach that I've been discussing, is that if your interfaces are based on domain-level requests, then gets and sets and destructive sorts of things tend to not appear in the classes at all. Right? See what I'm saying? In other words, it would be rare for a user to want to get some piece of information, because users don't want to get stuff, they want to do something. So you're defining your classes then in terms of what people want to do, rather than the data that the class contains. You shouldn't be thinking about the data. Right? The other way that that's usually stated is that you should ask for help, not for information. Instead of asking for the data that you need to do some work, you should ask the object that has that data to do the work for you. We call this delegation in an object-oriented world. And you want to delegate as much as possible. You want to delegate work to other objects. You don't want to get information out of the other objects. You want to have them do the work for you. So it's the same amount of work, right? We've got to do that code's got to exist somewhere. So this is really just an organizational principle. It's saying that code should be inside the object that has the data rather than outside of the object that has the data. And the advantage of that is that you end up with much less code. Because odds are, if you're getting a bunch of information to do that work, that you're going to have to do that work in 50 different places, which means that you're basically duplicating that code 50 different times. If you move the work into the object, there's no duplication at all. So the code ends up getting much smaller, much simpler when you approach things in that way. It's an organizational principle, but it's an important one. Now, going back here, though, the testing, though, this is particularly important in testing because you don't want your tests to break. If the test bar goes red, we're in deep trouble. And we really don't want to be in a situation where we make a small change and half of our tests stop working. So the more your tests depend on the implementation of the object, the more fragile they'll be. So when we start talking about a testing world, following these rules becomes very, very important, because we can't break stuff. We can't break our entire test suite because we had to change a float into a double or eliminate a field entirely. Everyone understand the point that I'm trying to make here? So these kinds of general object-oriented rules are very, very important with respect to testing, because it keeps the whole test process flowing smoothly. Otherwise, we waste too much time fixing too many bugs. So you don't want to assume anything about an implementation in a test, right? This is making assumptions. This is making a lot of assumptions here, because it's effectively doing a get value, right? We're assuming that it's a float, among other things, or a double, right? Something that could be represented in a particular way. So you want to avoid these get set methods. They don't help you. The other thing is that you want to change only one thing at a time when you do tests. You never want to be in a situation where the bar is red because 2 or 3 or 4 things have broken. You only want one thing to break. So you do things in very, very small chunks. The other issue is that you don't want to change the test and the object that you're testing simultaneously, because then you don't know whether the problem is in the test or in the object. So you should only change one at a time. You don't want to change both at the same time. The idea of the law of Demeter, right? You only talk to your friends. Is the notion of the law of Demeter, in other words, is that you don't want to go through intermediaries to get work done if at all possible. The classic example of a violation of the law of Demeter is the so-called train wreck code. The issue here is that there's a lot of dependencies here, right? For this to work, well, first of all, everything along this chain has to work. And if the whole thing fails, it's hard to tell whether the problem was here or here or here, or maybe even here. That might be null. So everyone understanding what the difficulty is. So I should say that there is another pattern that you see when you go into functional programming, where you see things that look like chains like this. The way that works in the functional programming pattern is that every one of these guys will either be returning dog or returning a function. And that's a different, it looks the same from the outside, but structurally it's different than what I'm talking about here. Okay? Now, the problem, as I said, the problem with the train wreck is that it is very, very difficult to find bugs. So we go back to that, ask the object that has the information to use that information. In other words, we don't want to get out the tail and tell it to wag. We just want to tell the dog, be happy, right? And be happy however you're happy is fine with me, right? If you want to wag your tail, that's fine. If you want to jump up in the air like a maniac, that's fine too. Right? So that gives us a lot of flexibility. I can express happiness any way I want to. Is everyone with me here? As long as I can say to the dog, ask the dog, are you happy? Then I'm happy. So now I no longer have the dependency on the tail object that I had in the earlier code. Final principle, is this the final principle? We're getting close to the final principle. Oops. So we want to clean up after ourselves. In other words, a test should leave the world in the same state that it was in before you made it. And that goes way beyond the program level. If you modified the database, unmodify it. If you change something in the file system, get rid of the files that you added or removed. Don't ever delete a file in a test, just move it someplace so you can move it back. If your test is going to create a file and a file with the same name already exists, don't delete that file, move it somewhere else, and then when the test concludes, move it back. If you don't do that, what you'll find is that you can't run an entire sequence of tests, because they won't be, the state won't be what you expect it to be. And it also means you can't run a test from inside another test, which is something you have to do occasionally. So everything you have to clean up after yourself as you're working. All right. So any questions here? So I'm gonna live dangerously here and try and actually code in front of you, as we'll see if this works or not. I had a long night last night, so we're likely to see the downside of testing more than the upside, but depending on how many mistakes I make as I type. But let's try and actually do it. Now, I'm going to do a couple more slides because these are the first part of the process, and it will save me a little bit of writing. First order of business is I'm going to use authentication here as my test case, just because I need to do something simple. Right? This isn't a full-blown story. I mentioned earlier that logging in is not a use case, right? It's not a story because there's no useful outcome. Authentication falls in the same category. That's not actually a story. Simply authenticating a user is not there's no useful outcome there. There's no work product of value produced. But it's going to be part of some bigger story, of course. So we might as well look at that in the sense of, if I'm working on a bigger story, I've got to think about that. Now, the first order of business is that if I'm creating a story, I have to do it within the context of what's called a system metaphor. And if you're thinking about logging in, there are lots of metaphors that come to mind, but one of them that's not a bad one is this notion of a guard asking somebody to sign in to a building as you go into the building. All right, is everyone following what I'm saying here? In other words, I want to keep this in the domain as much as possible. I don't want to go into the realm of computer programming, because one of the points of this exercise is to come up with a set of classes that have some connection to the domain. So I need some kind of metaphor that my users are going to be able to understand. I don't want to abstract to data structures immediately, because my users are not going to be able to understand that. So a lot of this has to do with the needs of communication as much as anything else. So if I'm authenticating a customer, the guard asks the customer to sign in. The guard finds the customer's signature card in a card file. And if the signature's a match, they allow the customer into the room. Right? Well, the signature is our password, right? The guard has to find the customer's signature in a card file. Well, how's he going to do that? He's got to clearly ask the customer for a name or something like that. There's a lot of implicit stuff here, but that's fine. So we have a login, right? We've got a username and a password here. We're just calling it a signature, and the username is kind of implicit so far. Though, now I could expand that out. I could keep this exercise going on in English, and I could keep expanding it until I captured every possible detail. But I don't want to do that. In an agile world, you don't need to do that, because I'm going to be coding very quickly. There's no point in writing something down on paper if I'm going to use that information 5 minutes from now. Now, the other thing that's important here is that you don't want to confuse the notion of the role with the notion of the end user. In other words, I'm trying to identify roles when I look at the card that we were just looking at. I'll come back to it in a second. Well, in this case, Frankenstein is the role and Karloff is the actor. Right? Now, the literature of use case analysis talks about actors, and I really hate that, because what they're really talking about is the role. When I'm defining any kind of story, I don't care about who's typing. What I care about is what role they have when they're typing. And if you think about who's typing as being the same thing as the role that they're taking on, then you will get into bad places. Taking a timesheet authorization system is a case in point. I do this because it's a system I worked on a few years ago. The fact that a person sometimes logs on to the system in the role of manager in order to authorize timesheets, and the fact that the same person sometimes logs on to the same system in the role of employee in order to fill out a timesheet does not mean that there's any connection between those two roles. Right? In other words, the is a test that you hear about in object-oriented design is of no value at all. The fact that you can say a manager is an employee is completely irrelevant in the context of this problem, because managers and employees have a completely different and non-overlapping set of responsibilities. It is the responsibility of a manager to authorize a timesheet. It is the responsibility of an employee to fill a timesheet out, and there is no overlap. So there is no derivation relationship there, none. They are two completely distinct classes that have perhaps users relationships between them, but they certainly don't have a derivation relationship between them. Is everyone with me here? So I don't care about the guy typing. What I do care about are the roles. So what are the roles on our card? Well, certainly there's a guard, a signature card, a card file, a signature, a customer, maybe a room. So those are going to be the basic abstractions in our system. Is everyone following what I'm doing here? So that's the first order of business then. We have to come up with a story, and we have to find out what the abstractions are. Now, looking at that, there are some issues with respect to the changes that might have to happen in the process of making that work. In other words, I'm looking at the story even, at the story level. And I'm going, well, you know, once I'm in the building, I have to somehow identify people as having been allowed in the building. Is everyone following what I'm saying here? So the easiest place to make that change is here at the story level. Is that if the signatures match, the guard issues a badge. Is everyone following what I'm doing here? Now, I could do that either at the story level, but I could also do it when I'm coding. But the important issue is that when I do the code, what I'm going to end up here is with a one-to-one relationship between the code that I'm writing, the abstractions that I come up with the story, and the classes that I come up with in the code itself. Is this making sense to everyone in terms of how this is going to evolve? All right. So let me get out of here for a second and get Eclipse up. I got to do this in Java just because I programmed in Java more recently than I have in C#, so I will make fewer mistakes. I'm assuming that we can follow along regardless of which way I go. Let me mirror the displays so that I can see what I'm doing while you see what I'm doing. Good. Is that visible? Should I make the font larger? I can make the font larger if I need to. You can't see it. Okay. First of all, there's a test file here. I just gave this test file to the guy who's putting together the notes for downloading that's going to be up on the website. So this source should be up there for you to download if you want to fool around with it. Not that there's much here. Let's just look very briefly at where I'm starting. This is my starting point. As I said, I'm writing it in Java. So I have two files. One of them is just a simple file that is executing a method. The other one is the set of tests that are going to be testing that little TDD object, the little bogus TDD object that we were just looking at. And I'm using Mockito here, which is the rough equivalent of mock, of MOQ mock in the .NET world. But the basic idea is that you have a set of classes. This is just the basic JUnit functionality, but you have a set of classes that could either set up the entire test suite or set up before or after an individual test. So one of our basic principles is that if you change something in a test, you should take it away, you should fix it afterwards, and before and after give us a way to do that. Before class and after class give us a way to set up an environment for the whole set of tests to run and to tear down the environment that the whole set of tests used. Inside that environment, each test is labeled here with as you can see, with a .test directive that indicates this is a test. All right, and I'm checking, there are various things that you can check for. In this case, I'm checking that we have a null pointer. This particular test is creating a spy around the system class. We talked about spies. The notion of a spy is to put a wrapper around something to make sure it works or to change its behavior. In this case, the spy is spying on the system class, and then here's my test framework saying, when somebody asks for the config property from the system object that we are defining, then return this string instead of the thing you would normally return. So this is a way of putting a wrapper around an object and changing the behavior of a method without actually putting a wrapper around the object and changing the behavior of the method. Whether this is easier to do or not is arguable. is that some of these tests, when I've written using frameworks like JUnit or PowerMock or any of those things, end up being more complicated looking than it would have been if I had just written a wrapper and gotten it over with. Right? So there's no rule, hard and fast rule that you have to be using this stuff, but it's worth using. The mock is kind of interesting. Here's I've created a sample interface, and now I can produce a mock of it just by saying @mock, and what this will do is actually implement that interface with methods that don't do much that's interesting, but we will get a full-blown implementation. And then I can use directives like the when directive that we were just looking at to change the way that mock behaves if I want to. All right, is everyone understanding how this is working? So this is my basic mocking framework. There's nothing particularly earth-shattering here. So let's think about the notion of doing some kind of test-driven development approach or domain-driven, or it's too, as I said, I had a long night last night, as talking is sometimes a problem, but we'll take a design by coding, a DbC approach here. Right? So we know as a fact that we're going to have a guard class. Right? There were also, what are some of the basic abstractions here? We had a card. Oops. We had a card file. What else did we have? We had a signature. Actually, I guess a card is a signature card, isn't it? Right, now, user, whether we're going to have a user or a customer here, that I'm not sure about. Because this confusion between the guy typing and the roles, right, is that certainly there's going to be a user typing. But is there actually going to be a role of user in this system? Right? And I would argue that there won't be. In other words, how would you fill out a signature card? Right? Remember, the guard was going to take a signature and was going to compare it against a signature card. Well, the signature really should be creating the dialogue onto which you enter the username and password, or the signature card should be. Right? Username and password are elements of the signature card. So that UI should be effectively created by the signature card. Whether it's physically created by the signature card is another matter. If we're doing a web interface, it won't be, right? There will be a little JavaScript and HTML that defines what this thing looks like. But effectively, from a design point of view, the signature card class is creating the user interface that expresses a signature card on the screen. The guy typing types in information to that card, but we don't model that. That's just somebody typing at a keyboard. Does everyone understand that distinction? It's an important one. So I'm not going to, I don't think I need a user card, a user here, a customer. What I do need is a signature card in the file to match a signature card that I get from my users. So everyone following what I'm trying to get at here? So let's try and start writing some code, writing a test of some sort. Let's see, what would be the best thing to start testing for? I want to test that a user or a customer with a card on file is allowed into the room, to stay in the realm of our metaphor. That's a rather long name, but it's pretty descriptive. And more to the point, if that's the name, then I don't need to document it because it's pretty self-documenting. So how am I going to do that? Well, first of all, I need the card, right? Is that I need to somehow get a card out of a file. I need a guard from somewhere, so let's assume that we have a singleton guard someplace. Oops. And now I'm in trouble, right? So how do you do that? Oops. How do you do that? You can't, because the guard is an interface. Is everyone following what I'm saying here? Well, again, if we look at the way that we would do this inside our mocking framework, which is the easiest way to do it, I can, oops, go back. Here it is. I can do it that way, which effectively does the new for me. Or I could actually make a small implementation. So the easy thing to do is the mock. So let's do that. So that's effectively going to create a guard for us. So everyone's with me so far. I've got this returning void for now. Make it happy. So now I have a guard. So now I can ask things of the guard, and the guard can do things. I should also probably make a signature file. Okay, is everyone following me so far? Well, now I have to ask the file. I'll get a card from, I have to get a card from somewhere, don't I? So I have to create a signature card. Now I'll do this as a presented ID, right? This is the ID that the customer is presenting to me as he signs in. Is everyone with me so far? Then at some point I have to say to the card file, do you have a card matching the presented ID? Okay, is everyone with me here? Now, that's going to give me a yes or a no, but we do have the problem of credentials, right? The badge. How do we deal with the badge? In other words, I know as a fact that I'm going to have to get some kind of indicator back here that prove that the guy was who they said there was, but I also have to get a badge. Right? Is everyone with me here? Now, there are a couple things to notice at this stage in the process. I thought about the badge back when I was looking at the story, but what if I hadn't? In other words, I'm sitting here writing this code, and I'm suddenly saying, oh gosh, I need to have some object that indicates that we have a successfully signed on user, right, an auth token or something in terms of implementation. And I don't have that here. So I have to then say, well, this is going to have to change. I have to learn how to spell matching. Right? Is everyone following me here? And I need my badge. But I don't have a badge class. So then I can introduce it up here. Oops. So here I've found a flaw in my story as I'm actually coding. I'm doing design, in other words. The point I'm trying to get across here is that in the process of just trying to work my way through getting this test to work, I'm finding flaws in the design of the system. And in this case, I actually found a flaw in the story. Does everyone understand what I'm getting at here in terms of making this work? Now we have a problem, though, right, is that this method doesn't exist on the card file class, so I'm going to have to add it. No, it's going to return a badge. Oops. Presented ID, what's that? That's a signature card probably, right? So now, again, I've done some design. Is that I start out by trying to write the code that is using this system, and that's told me what the name of one of the methods has to be, and I can see from the name what it has to do. Is everyone following here? Following me here? Now, I'm not particularly happy about the straight mock here because I want to actually write a test that's going to work. So I'm going to implement the interface. In other words, I'm just going to build my own mock here. It's going to have to look the same. And I want it to return, so let's make a mock of the badge. And I want it to return it. What have I done wrong? Okay, so now I've stubbed out this interface with just something minimal. The badge doesn't do anything yet, doesn't need to do anything yet, so I can just mock it. Is everyone following how this is working now? My test down here, well, now I have problems, right? Oh, it's being mean to me. I'm not going to keep doing this because I don't want to sit here and figure it out. But what I want to try and get across, though, is the process I'm using. Is everyone understanding how this process is working? Right, I can keep doing this all day, is that it works exactly the same way. I add a little bit of code in order to try and move things forward. That tells me I'm missing a class, or I'm not missing a class, or I have to add this method, or I have to change this method a little bit. I do the minimal amount of change that I need to get things working. It's not going to work now because it's not compiling it. But if I could get it compiling, I'd hit the test button and it would run and the test would succeed. And then I just keep going around and around that loop. Now, the important thing here, though, is that unlike pure TDD, my goal in doing it this way is to develop that interface. What I'm trying to do is develop the interfaces for guard and so forth and make sure that they all have in them exactly the methods they need and nothing else in order to work through one story. So when I'm done then, I'll have the interfaces done and I'll have a bunch of these little stubs for the mocks, right? In the same way that I got rid of the @mock and actually produced a class up there. I'd have these little classes. Now, those little classes are the basis for the real ones. And then I'm going to start flushing out the methods on the real classes, but then I'm falling back into the TDD world where I'm writing a little unit test for each method and then running the unit test to make sure that those work. So what I'm doing here is I am merging the software writing process with the software designing process. And there's nothing different here that I'm doing than I would be doing if I was designing with UML on a piece of paper. The only difference is that I'm using code as the notation instead of using UML as the notation. The process is identical. This is exactly the way I used to work when I was doing big upfront designs in UML. But since I'm going directly to the code, I save all the time that I would have otherwise spent making those giant pictures. And since I'm going directly to the code, at the same as I'm designing, I'm also producing this nice set of tests, which are pretty handy to have around. Okay, is everyone understanding what I'm getting at here? So that's the basic process. The basic idea is to use these tests as a way to do design, is used to uncover flaws in the interfaces and to develop an interface that's a minimal interface for the system that we're trying to develop. Okay, so I could go back to the last slide, which just has my name on it and a giant question mark, but I won't bother. So are there any questions, though?
Do you ever use whiteboards and class diagrams?
Do I use whiteboards and class diagrams?
Yeah.
Rarely. What I do use is CRC cards. Right? Everyone know what a CRC card is? It's a design aid that Kent Beck and Ward Cunningham actually came up with probably, 20 years ago now. And the idea is that it's an index card, and you write on it the class name, that's the first C, the responsibilities of that class. So if you take the guard class as a case in point, the class name is guard. It is the responsibility of the guard to verify that the presented signature matches the signature on file. That's his responsibility. And the collaborators, who does the guard have to talk to make that work? In this case, the guard's going to have to talk to the card file and probably to the card. Right, so I'll do that for every one of the abstractions in the system, and then I'll go over to the corkboard and I will tack up these cards on the corkboard, and then I will take little pieces of string and actually connect the cards with their collaborators. Now, if you think about that for a second, that is a UML class diagram. But it's a very flexible one. It doesn't have any of the methods defined, it just has responsibilities defined. But it is showing me all of the classes that comprise the system and the relationships, the dependency relationships they have between them. At least it's showing me the users' relationships. Now, derivation relationships, I don't do much derivation. That's a different session entirely, which I'm not doing at this conference. But generally speaking, implementation inheritance is a really bad idea. Extends relationships. Interface relationships, those are great. But extends relationships where you have a subclass and a superclass, it's a really bad idea. If you want to do something offline, you should Google the phrase fragile base class and read about it. But fragile base classes are a big deal. So I tend to not have derivations, so those don't appear on my corkboard. So no, I don't use a whiteboard, but I use this equivalent. The one UML diagram that I do use a lot is an activity diagram. Because if I have a big complicated story and I'm sort of having a hard time keeping track of what the flow is through this story, I find that activity diagrams are pretty handy for that. But I don't use any of the dynamic model stuff, right? Sequence diagrams and stuff like that is that I figure the code is just as good a way to describe that as a picture. And I use, for the static model, I use my corkboard with the CRC card stuck up on it. Any other questions? Well, I will be here for the remainder of the day, so please feel free to collar me and ask me any questions if you have them. And thank you very much for coming to the session. Have a nice because I'm not spending a lot of time staring at the code trying to figure out whether it's going to work or not, is that programming, as we all know at least, is largely an intuitive activity, right? You do what looks good. You do what feels right. And it's not an analytical activity, as none of us do mathematical analyses of our programs in order to determine whether they're correct before, as we're coding or before we decide to run tests on them. That's an interesting academic exercise, but it's not the way that we really work. So if we can just program by the seat of the pants, if we can program intuitively, thinking this is the right way to do it, we actually develop code faster than if we have to sit and do a lot of analysis on the code as we're working. So having a large number of small tests in place and being able to run them in an automated fashion allows us to work that way, because we can tell immediately when our intuition has led us down the wrong path. It makes it easier to refactor, is that refactoring, as we all know, is the process of taking a piece of working code and making it better without breaking it. We don't change what it does, we just make the code quality better. Well, if you don't have these kinds of tests in place, you cannot refactor. It's that simple. And this is a good example of how agile processes tend to mesh with each other and interact with each other, is that one of the common agile practices is this notion of test-driven development, right? Is writing the tests first. But then refactoring is a big part of any kind of agile process. Aggressive refactoring. Merciless refactoring is the phrase that they often use. The thing is that you can't refactor if you don't have the tests. It's not possible. And when a company is moving to agile from a non-agile way of working, the first thing you always have to do is write the tests. There are never enough tests if you have not been working in an agile way. So the very first thing that you have to do, and just to make the code usable, you make the code maintainable, make the code so that it can be expanded in a flexible way, is to put tests in place so that when you make the changes, you can guarantee that you haven't broken anything. So the very first thing that any company has to do if you're thinking about moving in an agile direction is to spend 2 or 3 weeks doing nothing but putting unit tests in place, because I can guarantee you're not going to have enough of them. One of the advantages of another advantage of writing the test first is you end up with 100% code coverage. Now, that will become more clear as I go more into the process, as I describe how the process works. But the test coverage ends up being very, very complete, for the simple reason that what we're doing is allowing the story to drive the code development. And again, I'll get into more details in a moment, but the basic idea here is that we write up an acceptance test first. And the acceptance test is going to be doing something. It's actually going to be walking through the story. It's going to be exercising the system, walking through the story as if the system existed. So we're writing to interfaces. We're not actually writing to real code, because the code doesn't exist yet. But the important issue here is that if the interface is a minimal interface, and it always should be, in other words, the interface that we're coding to does exactly what we need it to do in order to implement the current story and nothing else. And then when we go to implementation, if we implement exactly what we need to do to make the story work, or to put it another way, if we implement exactly what we need to do to make the test pass and nothing else, then we have no unnecessary code. Every line of code that we have written has been focused like a laser on getting the current story to work. And since the test is what's driving that process, what that means is we have not written a single line of code that's not going to be exercised by the test. And that's really important. So we end up with 100% test coverage, which is a hugely important thing. And the other thing that we get out of that is we get the minimal code set. So what you have to resist if you're going through this process is the tendency, which we all have, to look at something like a function call and go, if I only added this extra argument, it would sure be a lot more flexible. You don't ever want to do that. Because if you add that extra argument, you're going to be adding paths through the function that are not tested, because it's covering some future eventuality which is not in the current test. Moreover, you're going to make the function more complicated. It could be as much as 2 or 3 times more complicated than it needs to be in order to handle the extra argument. One of the basic metrics that one uses to measure complexity in code is cyclomatic complexity. You can buy and also download now, there are open source tools that will analyze a program for cyclomatic complexity. It is by far the best measure of complexity that you can have. And it's doing a very simple thing. Basically what it's doing, have a lot of documentation. The issue is that the documentation is at a place where it will do some good. Or to put it another way, if you have a document that is separate from the code, first of all, the odds of that document actually describing the code are 0. Right? You'll spend a lot of time putting the document together, but within 10 seconds, the code will have changed and the document will have not, and you've got nothing. The other problem with those kinds of documents is that most of us realize that problem. So HP did a study of documentation, probably 15 years ago now, a long time ago. And one of the things that they found is that nobody reads it. And you'd think that we would have all known that, right? How often have we actually read the documentation for the systems that we're working on? Even when we come into the company, right, as a brand new employee, you pick up this huge stack of documentation and read about 3 pages of it and say, the hell with this, and you go find somebody who can explain it to you, right? Is that nobody reads that documentation. So from an Agile point of view, we would say that's waste. No reason to build it. What we do want to do, though, is we want to write the code in such a way that it is self-documenting, which is to say that the documentation is the code itself. So it's not like there is no documentation. It's rather that the documentation and the code come together. So when you need comments, obviously that's part of the documentation. When you have some kind of preprocessor that generates HTML documentation, that's also part of the documentation. And everything is dynamic, though. If there's anything written down, it's written down in a wiki format, typically, so that it's easy to change. So the problem I'm trying to address here, then, is how to write this kind of self-documenting code in an incremental way, so I don't have to do a lot of upfront design before I start actually coding. So that is the problem at hand. Now, I made a little video about this. So if you want to follow on to the things that I'm saying, this is about a 10-minute long video that will distill pretty much everything that I'm going to discuss over the course of the next 90 minutes. I have it up on my website. I also put it up on YouTube. Because that's just the Google thing is just a shrunk version of the longer YouTube URL. But the process is pretty straightforward and it's pretty easy to describe. So it's built on top of TDD. TDD itself is a design practice, which is something that people don't understand when they look at it. They think of test-driven development as being a way to produce. Morning, everyone. This is a cavernous space. I hear this echo that I'm not used to that in the other rooms. What this talk is about is something that I call design by coding, which is really, as I say in the subtitle here, extension of the whole notions of test-driven development, or test-driven design is actually how I like to think of it, and also of behavior-driven development. So I'm going to look a little bit at all three of those things. I'll look at how I do things, but also look at the underlying systems that I'm building on top of. The basic problem that I'm trying to address is the problem of developing code in an agile environment where you are designing incrementally as you're working. Is that what you have in front of you is a story, is a unit of work, and you want to design in such a way that you can add the capabilities required by the current story in a way that will give you architectural consistency over time as the whole system is developing. And you can do that in many ways. It's a continuing thread through a lot of the sessions I've been giving in this conference is that at the center of this is object-oriented thinking in the sense of modeling the domain in order to produce a program and getting a one-to-one correlation between the domain model and the software. So if, for example, you've got a ordering system, you'll have an order object and a customer object, and the customer might have an address object in it, and the order might have line items in it, and the line items might have, inventory items in them, and so on and so forth. But those are all domain-level concepts, and they would map directly to classes inside the systems that we were building, assuming that we're building in an object-oriented language and we have classes. So the idea is to try and keep that one-to-one correlation. So the question is then, from a development point of view and also from an agile point of view, how do you do that without having this massive upfront design effort and also a massive pile of documentation? The documentation in particular is anathema in the agile world, though people misunderstand that. As often I will hear people who don't understand agile saying, well, agility, we have no documentation in the agile world, and that's not actually true. Tests, because it has the word test in its name. And in fact, when you learn about agile process, often you will hear the exhortation that you should write your tests first, which in practice you might or might not do, is that you will certainly write your tests at the same time as you write the code. Whether you actually write them first or not is another matter. Some of them you will write first. The acceptance tests you write before you write any code. The unit tests you might write as you're writing the code or not. Now, if you're doing strict TDD, you will do the unit tests before you start writing the code also. The basic thing that people don't understand, though, is that the point of those unit tests is to be able to write the correct code. The point of the unit test, in other words, is to find flaws in your thinking. In other words, you're doing a design process if you're finding flaws in your thinking. The tests that you end up with are useful tests, but it's nothing like the full set of tests here that we need in order to actually make sure that the program is working. So any kind of tests that come out of any kind of TDD-based process are going to be incomplete by their very nature. Because the point of the exercise, then, is to develop good code, not to develop tests. The fact that we get a bunch of nice tests, well, that's nice, but it's, it's really a side effect of the process. It's not something that we're aiming for. So what are we trying to do by doing this process? We're trying to, well, remove stress. Is that if your tests are in place, it's way less stressful to work on the code. Because if you run the tests and they work, and then you make a change, and then you run the tests again and they don't work, you know exactly where the problem is. And when you're doing any kind of TDD sort of work, you are testing, I don't think I go more than 5 minutes without running my tests. And 5 minutes would be unusual. It's typically I'm running them once a minute or so. So the side effect of that, of course, is they must be automated. There's no way that you can do this kind of testing if it's not automated testing. But it takes all of the stress off the code. I never look at a piece of code and stare at it for 10 minutes to try and figure out whether or not it's going to work. I just run the test. And if it doesn't work, it's probably going to take less time to just throw it out and rewrite it than it will to try and figure out what the problem is. So it radically changes the way in which you put code together. As a consequence, it's also reducing my development time.